what we were looking at when we looked at My Maths Online and those few slides, we say that a to the power of y, you know how we say a to the power of what gives me x. So if y is my answer, if y equals log to the base a of x, we say a to the power of y equals x. Are we okay with that? Remember, we were looking at things, we'll do some examples of what we were looking at before. The main thing here is that a must always be positive. So the logarithm base a, see, the logarithm base a of a positive number x, where x is the index. So when the number x is expressed as a power of the base a. So x is a power of base a. X is a to the power of y. But just learn it this way. So a to the power of y is x. Okay with that? The thing here is that the base a is greater than 0, and the base a cannot equal 1 in these questions. All right? So this is the log law, log rule. So if y equals log to the base a of x, then x equals a to the power of y. So for example, log to the base 2 of 8 equals, someone tell me? Yeah, we say 2 to the power of what is 8. So it's 2 to the power of 3. This means that, how else could I write it? Remember what I was saying before, that 2 is the base. Doesn't that mean that 2 to the power of 3 equals 8? Okay? So how are you going to remember how to do it? Log to the base 2. 2 is the base. So 2 to the power of 3 is 8. Okay? The base of the log is the base of the power. And notice that the log is the index. The log here is 3, because log to the base 2 of 8, what is log to the base 2 of 8? It's 3. So the log, the answer basically here is the index, and the base of the log, which is 2, is the same as the base of the power, 2 to the power of. Okay? So this is from your textbook. Just rewrite in log form. So 10 to the power of 3 is 1,000. How would I write that as a log? So, I know you can't see it. So, how do I write that? That's like giving you 2 to the power of 3 is 8. How do I write it as a log? The other one, 3 to the power of 4 is 81. How do I write that as a log? So, how do I... Remember, the base is the base of the log. So, I say log to the base 10 of what? Of 1,000 is 3. 10 textbook, rewrite in log form. Okay, so we looked at this one. Log to the this would be log to the base 10 of 1,000 is 3. Remember, the base is the base of the log. 3 is the base. So it's log to the base 3 of 81 is 4. Because we're saying 3 to the power of what is 81? 3 to the power of 4 is 81. Another example. So rewrite these in index form. So rewrite in index form. So we're just learning to go from one form to the other. Log to the base 2 of 16 is 4. And log to the base 3 of 27 is 4. And one of them is not false. And indicate whether it is true or false. Indicate whether the answer is true or false. That's example 11. This is example 12 in your textbook. So how? Rewrite in index, form and indicate whether the answer is true or false. So what do? 2 is the base. 2 to the power of 4 is 16. Is that true? Yep. And the other one, this is saying that 3 to the power of 4 is 27. Is that true or false? No, it's false. Because what's the answer here? What should this be? This should either be 81 or that should be a 3. All right, we know that the answer log to the base 3 of 27 is 3, or it should be log to the base 3 of 81 is 4. They're actually, those two are correct statements over here. This is an incorrect statement, that log to the base 3 of 27 is 4, because we're saying 3 is the base, so it's my base here in my index. 3 to the power of 4 is 27. That's not true. Okay, write in index form and solve. Okay, 10 is the base. How do I write it? 10 to the power of what? 10 to the power of x is 1,000. What's the answer? X is 3. I can write that as 10 to the power of x is 10 to the power of 3, but the x is 3. Because 10 cubed is 1,000. The next one. So that one doesn't need much working. This one will. So 10 to the power of what? 10, yeah, good. 10 to the power of x is 1 over 100, and you could say that's 1 over 10 squared, which is 10 to the negative 2. It's okay to put on the 1 line. So therefore x is negative 2. And then keep going with the ones underneath. Which one's the base? Sorry, 8. So we write 8 to the power of x is 64, which happens to be 8 squared. You can write it like that. Are we good? X is 2. Keep going. X is 1 over 64, which is 1 over 4 cubed, which is 4 to the negative 3. So x is negative 3. 5 is the base. So 5 to the power of negative 3 is x. So x is 1 over 5 cubed, which is, all good? Come on. 1 over 125. Keep going. 4 is the base. The log, or the answer, is your power. 4 to the x is 3. You can see that you can't do that at the moment, but by the end of the lesson we'll be able to. Or actually, so it's log to the base 4 of x is 3. Sorry about that. So what do we got? Log to the base 4 of x is 3. So what do we do? 4 to the power of 3 is x. So x is 64. Okay, question 6. Again, write in index form and solve. I'll just put solve. Log to the base x of 8 is 3. So you can see this exercise is very doable. Log to the base x of 1 on 49 is negative 2. Question 7, again, solve. Okay. Evaluate or solve. And the last one. So what have we got? Okay. Question 6b. What have we got? That x to the power of 3 is 8. So therefore, we know that, well, 8 is 2 cubed, isn't it? So what does x equal? 2. Yeah, so that's how you can write it. So we know that x to the power of 3 is 8. I know that 8 is 2 cubed. So the powers are the same. Now I'm comparing the bases. So doing the same thing with the next one. X to the power of, x is the base. X to the power of negative 2 is 1 on 49. Do you want to rewrite your 1 on 49? It's 7 squared, which is 7 to the negative 2. The powers, so with all the others, we're making the bases the same. Now we're making the powers the same because we're trying to find the base. Okay, so what is the x equal to in this case? 7. Okay, so keep going. a to the power of x is a. So x is 1. Because a can be written as a to the power of 1. All right. The next one, a to the power of -1 is x. Just rewrite it. X is negative. No, how do you write a to the -1? 1 on a to the 1, which is 1 on a. Oh. So log to the base a of 1 on a is -1. Keep going. Let that equal x. Oh, so I've got a to the power of x is 1 over a to the 5, which is a to the -5. Therefore, x is -5. Now I can put that equal to x when it asks me to evaluate it. Okay? And the next one, evaluate that. If I put it equal to x, a to the power of x is square root of a, which is a to the half. Good. So therefore, x is a half. Okay. Okay, now our calculator and what our calculator can calculate with logs. There are 2 log functions on your calculator, and the one that will that you will notice first is the log button. Now the log button on your calculators allow calculations of logarithms to base 10 using the log function. Now that log function, log, on your calculator really means log to the base 10. Okay? Now it could be on, is it on a key on its own? Is 10 to the power of x above it? Okay, so on your calculator, you've got log, and I believe in orange, 10 to the power of x above it. The reason the 10 to the power of x is above the log is that it's the inverse function of the log to the base 10 function. So 10 to the power of x is on the same key as log. Okay, and we access 10 to the power of x by using the shift function because log to the base 10 and 10 to the power of x are called inverse functions of each other. Now, what that means is, when they are used, if you do a log followed by a 10 to the power of x, you will get the original number. So when they are used one after the other, the original number will return. That's what inverse functions are of each other. So log to the base 10 and 10 to the power of x are inverse functions of each other. Now, I'll show you an example of what that means. Well, if I do 10 squared is 100, but also log to the base 10 of 100 is 2. Okay? Oh. 10 squared is 100, log to the base 10 of 100 is 2. So if you do 15 on your calculator, write in log form, then use the log function on your calculator to approximate x to 4 significant figures. So these are the 2 examples. How do you write these in log form? Remember, 10 is the base. That's the hint. Log to the base 10 of 750 is x. See? 10 to the power of what is 750? So now you just grab, on your calculator, you just press log 750. So you can only do, at the moment, log to the base 10 on your calculator. We can also do log to the base e, but I haven't shown you that yet. All right? So the log button on your calculator is a log to the base 10. All right? So now you can work out that on your calc, it's just log 750. So if you press log 750 on your calculator, it is actually log to the base 10. What do you get? 2.8751, etc. We want 4 significant figures. 1, 2, 3, 4. 2.875 is the 4 significant figures. It means 4 figures. Leading digit cannot be a 0. Zeros at the beginning are not counted, but zeros at the end are. So the next one, remember the base here is the base. 10 is the base. That means that log to the base 10 of what? Of 0.003 is x. So if you're entering that on your calculator, you just press log 0.003, because log on your calculator means log to the base 10. What do you get? Negative 2 point, yep. So to 4 significant figures, it's negative 2.52. I need one more figure. I've got 1, 2, 3. Okay. We say 9 is the base. So 9 to the power of a half is x. So x is 9 to the power of a half, which is what? Square root of 9, which is 3. Next one. 6 to the power of x is cubed root of 6. So how else can we write cubed root of 6 as a power? 6 to the third. Now the bases are the same, therefore x is a third. All good? X to the power of a third is 2. What's the power of a third in terms of roots? Which root? Cubed root. This is asking the cubed root of x is 2. That's what it's asking. So when we see x to the power of a third, that's cubed root of x. Cubed root of what is 2? 2 times 2 times 2 is... I could, let's say you didn't know it. What's the inverse operation of cubing? Sorry, of cube root? Cube. So you could cube both sides if you weren't sure. So if I'm trying to solve for x, I have to undo the cubed root of x. So I could cube both sides. Cube both sides. Okay, cubed root and cube cancel. And I get that x is 8. The next one, 7 is the base. 7 to the power of a half is 49. That's really the square root. No? Yeah, 7 to the power of half is x. Oh, x is just what? The square root of 7. That's it. Done. Yep. And we've already solved for x. Yep. And you've got 2 more. Are we okay with that? 4 to the power of x is a half. Writing 4 as 2 squared. Yeah? So that's 2 to the power of 2x is, how can I write a half? 2 to the negative 1. So 2x is negative 1. X is negative a half. I think you realise that the square root of 4 is 2. See, because you know that the square root of 4 is 2, but it's 1 over. So that's why it's negative a half. Probably safest to do those like this. W. What's the base? X. X to the power of negative a quarter is a half. Okay. That's a negative power. This isn't. Why don't we write this one as a negative power? X to the power of negative a quarter is 2 to the negative 1. Okay. Think back here. How am I going to get rid of this? What could I do? Couldn't you do the same thing to both sides? Why don't I just take the power of 4 to both sides? You know, here I cubed both sides. I want to get rid of this quarter. I don't even think it's going to help to write negative 1 over 2 squared. It's not going to help. So we can take the power. You know how you're allowed to square both sides, cube both sides? See back here, I could have written cubed root is 2, but I could have actually just cubed both sides here and gone like this. I could have gone take cubes of both sides and solved it. Okay? Or, look, that's the 1 over the 4th root. I mean, we can try it. We're going to try this a couple of ways, all right? If you want, you can say that this is 1 over the 4th root of x. Oh, yeah, that will work too. We're going to do it 2 ways, okay? I want to take powers of 4 of both sides. But then I'm going to do it another way. Take power of 4 of both sides. You're allowed to do that. So x to the negative a quarter, take that to the power of 4 is 2 to the negative 1 to the power of 4. Negative a quarter times 1 is negative 1. This isn't, oh yeah. This is not help. Oh yeah, we can do this. What else do I do now? This is not the best method. Keep going. It's all right, you'll get questions like this where you choose the bad method. Come on, what does x to the negative 1 mean? 1 over x, 1 over 2 to the 4. What's x then? Look at those two. If the 1 overs are the same, then x is 2 to the 4. If you're comparing the left and the right-hand side. I'm going to show you a more direct method of doing this in a minute. Probably shouldn't have done it this way. That's okay. What's that equal to? 2 to the power of 4. Do you know why I'm able to compare both sides now? You've got 1 over, the denominators have to be the same. Now, that's not the best way to do this. We're going to do it another way. Okay. We're going to do it another way. Let's go. This means that x to the power of negative a quarter is a half. So I'm going to change how this looks now. Okay. Isn't that 1 over x to the quarter is a half? Yeah. What does power of a quarter mean? 1 over the 4th root of x is a half. Okay. Now, all you're doing here is 2 times 2 times 2 times 2 is 16. So the 4th root of what gives me 2? What number, this is saying what number multiplied by itself 4 times gives me, what number multiplied, so 2 multiplied by itself 4 times should give me the number under here. You know, like when you do, I'll show you. You know how the square root of 4 is 2? 2 times 2 is 4. The cubed root of 8 is 2 because 2 times 2 times 2 is 8. Do you get it? The cubed root of 16 is 2 because the 4th root of 16 is 2 because 2 to the power of 4 is 16. So 2 to the power of 4 is 16. So in this case, x is 16. Because the 4th root of 16 is 2. So now I can go here. The 1 overs are the same. So the 4th root of x is 2. Let's say if you're stuck and you can't do that, you could still take powers of 4 to both sides. How do you undo a 4th root? You take a power of 4. Opposite of square root is squared. Opposite operation of cube root is cubed. Opposite operation of 4th root is power of 4. For example, the square root of, say, 3, which you don't know the answer to, but if you square that, you get 3. Yeah? Squared and square root cancel each other out. Let's say the cubed root of 7, which we can't do, but we cube that. You get 7. The reason is the cubed root of 7 is 7 to the 3rd, isn't it? Cubed root? Cubed root means power of a 3rd. If you take powers of 3 of that, you get a 3rd times 3 is 1. You can do it on your calculator. Cubed root of 7, get an answer, cube it, you go back to 7. Because cubed root and cube are inverse operations. They undo each other, and you end up with the same number you started with, which is the 7. And same here, 4th root. Inverse operation is taking powers of 4. So what I'm really doing is taking powers of 4 to both sides. Okay? One more example. Log to the base 9 of 27. So let that equal x. So 9 to the power of x is 27. Yep. Now what do? 3 squared to the power of x is 3 cubed. All good. 3 to the power of 2x is 3 to the power of 3. So then you can equate your powers once they are the same. Okay? Log to the base 9 of 27 is x. 9 to the power of x is 27. Whenever you've got numbers like this, you must reduce them both to a common base. And the common base between 9 and 27 is 3. So 9 is 3 squared, 27 is 3 cubed. So 3 squared to the power of x, we multiply the indexes. Remember that rule? am to the power of n is a to the m times n. Yes? Remember those rules? Okay. So once the bases are the same, you can equate the powers and you end up with 2x is 3 and so x is 3 over 2.